Okay, here's part 3 then. Just a reminder of this trick. I'm going to do this 2 ways. I'm going to do it just using my trick, which I am pretty certain will always be good. They do occasionally put some sort of slightly vague wording in, like, showing your full working. So I'll also remind you of the proper proof for it. Okay, so well, go on, see if you can remember the trick. Pause the video now and have a go at working out the value of R and the value of alpha. Sorry, I didn't say whether to use degrees or radians. I'm using degrees. Right. So looking at mark schemes, that is always acceptable for R. They always show a bit more working for alpha. I'm sure that that's okay, unless it's one of those ones that says showing full working. So just a reminder about where this comes from. So what we do is we use the sine A plus B formula to expand that. Okay, so I use the sine A plus B formula, which gives me sine x cos alpha and cos x, sorry, that's a cos x sine alpha, and then that's multiplied by R, so both of those terms get multiplied by R. And we want this to be this, so I've made that equal that. And then we just use that process called equating, where we say, right, we've got a constant, alpha is a constant, so the cos of alpha is a constant, but a variable, because x is a variable. And if we compare the sine x's on both sides, we've got r cos alpha times sine x on the left-hand side and 5 on the right-hand side. Compare the cos x's, and then we just do bottom equation divided by top equation, giving me that, and then the r's cancel out, so we get tan alpha is 5/5, which is what we had there. So I wouldn't worry about that if I was short of time, but if I had time, I might go back and fill that one in. Okay, so let's now take our original equation and let's say hence solve 5 sine x plus 5 cos x equals 3. And you may remember that we actually have seen an equation that says solve that without doing that bit first. So there are a couple of approaches. We could square both sides, although we need to check for spurious results, or we can remember that we can write that like that. Anyway, in this question, we've expressed it first. So we've said, right, that is 5 root 2 sine x plus 45. And so and I haven't given a range of values, so let's say we're asked to solve for x between 0 and 360. This is where, and I know it's very last minute, but I've changed what I think we should do. I think we should use our graphical calculators to solve this. Now, if that's going to throw you, don't worry, just do what we've always done. We say, right, okay, so if we're solving for x plus 45, we go a little bit further, and we do shift sign of that, find our solutions, and then subtract 45 from them. If you're happy with that, brilliant. But actually, it's a lot quicker, and I think there's a potential that for some of you, it's going to be a lot more reliable to use our calculator. So I am going to use my calculator. So I'm going to plot y equals that and y equals that. So y equals, I'm in degrees, yeah, in degrees, y equals sine of x plus 45 and y equals 3/5 root 2. I'm going to draw that. Now I was already in a sort of sensible set of axes for trig. If you're not, don't forget V window, and the trig button here gives you a nice sensible set. So my solutions are where the two lines intersect, where that equals that. So I can use gsolve and look for intersections. And remember, I'm looking for intersections between 0 and 360. So no, 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 Yes. 109.8, so I guess that's 110 if we're working 3 sig figs. 340. No, too big. And you know, there's never any indication in the mark scheme that they're expecting more method in between those two. So I think we would be okay doing that. If this way works for you, then that's fine. But I think that's definitely a quick way. And I would use that with any trig equation, I think, now, just to make sure we're getting those solutions reliably. Remember, because we've plotted sine x plus 45, we don't need to then subtract 45 from these solutions. Those are the actual solutions. They're the same solutions we would have got using the alternative original method. Okay.